Welcome to the KSSP podcast. I am Katie.
And I am Spencer.
And today is Science Thursdays. What we do on Thursdays is we appreciate science. We delve into it a little bit. Today's going to be a little bit more of a visual day. We're going to be looking at some photos from different telescopes.
Yeah.
All right. And I can share my screen here, and we're going to look at the Hubble Space Telescope photos from NASA. All right. So this first photo here, Hubble views a turbulent stellar nursery. The lives of newborn stars are tempestuous, as this image of the Herbig-Haro objects HH1 and HH2 from the NASA ESA Hubble Space Telescope depicts. Now, this is pretty cool. Basically, I think it's just the temperament of the stars is more unpredictable as they're newborn, if I'm understanding this correctly.
Yeah, I guess I'm not going to pretend that I'm super knowledgeable on it all, but I just think it's so beautiful too. And I know it's like the telescope too, but it's just beautiful, just space in general. But that is a really cool, I love all the pictures, but
yeah, all of the pictures are absolutely beautiful. Here, it looks like a comet to me. Twin tails, a new image after DART impact.
Was that maybe I wonder if
I'm not going to pretend I'm 100%.
Let me just Google DART impact quick.
Yeah. We're going to learn what that is together.
The DART spacecraft impacted Dimorphos. That might be butchered pronunciation, and I apologize if it is. Nearly head-on, shortening the time it takes the small asteroid moonlet to orbit Didymos. Didymos. So the Didymos system is an eclipsing binary as viewed from Earth, meaning that Dimorphos passes in front of and behind Didymos as it orbits the larger asteroid as seen from Earth. So
yeah, that was, not gonna lie, I didn't understand half of that.
So basically it sounds like a DART spacecraft impacted Dimorphos nearly head on. And Dimorphos is a minor planet moon of the near-Earth asteroid Didymos. So I guess I don't know. Did we do that on purpose? I don't know. That's my question. Was that something that, because it says after DART impact, so in my head that means we meant to impact it, but maybe it was accidental. I guess
it could have been a miscalculation too.
Because they recently tested, but I don't know if that's what this was. But because you heard about how they recently tested asteroid. What was it to stop an incoming asteroid if it was heading towards Earth? Some system that they tested recently to see if it works. Really, see if we could. And if I remember correctly, it did. It was successful. So I don't know. I don't think that's what this was though.
Yeah.
But
because this was a satellite collision with a moon that was orbiting an asteroid or a small planet, I think.
Oh, I guess NASA's double asteroid redirection test is DART.
Oh, okay.
So it was the world's first planetary defense technology.
Yeah, that's super interesting.
No, yeah, that's it's cool that they were able to like capture it too. Like obviously
Yeah,
they would want to see it to know, but it's just really cool that we obviously have the technology able to capture stuff like that.
absolutely. I'm gonna go to the next picture here. And we see Hubble Eyes, a brilliant star cluster.
Oh,
Absolutely stunning.
I
This
love that.
this image is taken with the NASA ESA Hubble Space Telescope. Shows Tesran 1, a globular cluster that lies around 22,000 light years from the Earth in the constellation Scorpius. Ooh, shout out to the Scorpios. But yeah, I'm actually curious how these globular clusters are formed. Globular clusters formed. Awesome. From giant molecular clouds or huge masses of gas that form stars as they collapse. Because there's less free gas available now than at the beginning of the universe, globular clusters generally cannot form today.
Hmm.
Interesting. Because this is so far away, this is actually like in the past if you think about it.
Yeah,
You know, it could look completely different now.
which that's just a crazy thought, but
Right. I mean, 22,000 light years away. Like, that's pretty far distance.
because how far is a light year? Like, what is what how would we be able to visualize a light year? Like, is it this like?
Well, not in miles.
That's a lot of miles there.
They don't
Um,
even, yeah.
well, like if you like how far? Because is a light year the sun to Earth? Probably not. That is
Here we
probably
go.
stupid to ask, but I just want to know if there's like a distance from like one, like maybe
Yeah.
a galaxy to a galaxy would be a light year, or
Well, how many light years away is the sun?
yeah, there we go. See, we figure out what we want to know.
Okay.
That's
That's not, how many light years did it take to get to the sun? So not very far. Not a lot of light years to the sun. We can try the Andromeda Galaxy, because I think that's the closest galaxy to us. And that is 2.537 million light years. These numbers are just blowing me
interesting.
away.
Yeah, no, they're
So this cluster
it's
is fairly close to us then.
wasn't it
Mm,
22,000? Or wait, hold
Yeah,
on. Will you
this
go back?
one, yeah. And this cluster here is 22,000 light years from the Earth.
Oh, I would have.
I would have thought it was much farther.
Yeah, interesting.
But it's still a far distance. I mean,
Well,
it's not like
yeah.
we're flying there tomorrow in a spacecraft.
No, I don't think anyone would, unless we had cryostasis. I don't know if people would. Unfortunately, the human body was not made to. I mean, maybe with future
And I mean,
technology, we'll live forever. But right now, I don't think we can live for 22,000 years, light years at
and
that.
yeah, because I think you age slower in space too.
Because there's less gravity, right?
Yeah,
Maybe.
and there's
I don't know if that's what. But I mean, it kind of, because then gravity's not pulling
yeah.
down on your body. But also, I think there's like negative effects of not having gravity in space that astronauts
Oh,
suffer from too. So
oh yeah. I think it's more when
don't
they
they
put
lose
that
muscle
out
mass?
there.
Because don't they lose muscle mass up there? And
Yeah,
I think
because
there's
they don't
something
have that
else.
force of gravity to
But
like
one
push you
thing that I always would have considered would be being a nurse in space. That would be amazing. Like that.
That would be a cool job.
That I would definitely consider going back to the nursing field. Like right now, I don't foresee that. But if I could be a nurse in space, and just even like the learning about what happens to the body in space, like doing study, oh, that would be really interesting to see and just be a part of too. Although getting up to space, I hate heights, so maybe if I was like put under on the trip up, so I didn't have
Yeah.
to think about it.
Mhm.
But I just think going to space sounds really cool,
Right.
but the reality could be really like frightening, obviously, because
Yeah, it can be both. It can be
yes.
exciting and terrifying at the same time.
But
But
I
I
would say
think,
don't let fear stop you
yeah,
from chasing your dreams.
just imagine looking out of like your window and seeing this,
Ah,
like in person, how bright the stars would be.
so I really want to go to like there's like countries where you can go where like the sky, like I always want to see the aurora borealis somewhere.
Ooh, yeah,
Like,
that
and I
would
think
be on my bucket list.
I really want to go to Norway because in my
Yeah,
head I've been told Norway has some really beautiful night events, but and
yeah, they
also
do
just
have
Norway's
auroras up there, I
beautiful.
think. Yeah, yeah, they do have auroras up there, I'm pretty sure.
So that's a dream of mine eventually too, I think. That could change though, but
All right. And this one I absolutely love.
whoa.
The, this is ultra speedy jet blasting from a star crash. So it looks like these two stars collided, and it looks like this jet stream here is a result of them crashing, if I'm interpreting this correctly.
That makes sense. If only we could like harness that energy.
Yeah, that would
Like
be really
if
useful.
we had the technology to collide two suns, I know we don't, so you guys can say I'm far-fetched and that's fine, I accept that. But if we could create that technology to like throw two suns together, just imagine the amount of energy released. If we could harness that, couldn't we like
Uh,
end our energy crises? But there's probably going to be negative effects that also has like
oh
other.
yeah. I mean, especially if like the UV and the light from the sun is, can give you melanoma, things like that.
Yeah,
I'm not sure
and
what kind of.
obviously we wouldn't do it with our sun because we need our sun. But then
Oh yeah.
also with that comes, are we taking away, like if we were to develop this technology and then start doing that to stars, are we like ethically, are we destroying the potential life on other planets because we took away their sun, you know?
Yeah.
So there are some ethical things that hopefully people would think about if we ever develop this technology before just going about and doing it. Just making sure obviously there is no signs of and whatever we consider life to be can
Yeah.
be a perspective too, but interesting thoughts because they're just thoughts right now, they're nothing, but definitely would want to consider, in my opinion, because
Yeah.
we shouldn't take away some other planets potential for life just because we as a species think we deserve more energy. Like that seems wrong to me, but
Yeah. But if they could do it, you know that they would, because
yeah, some
it's not
people.
just self-interest at the end of the day for a lot of people that have
But
that
I
power.
think I think we're learning.
Yeah.
I'm hopeful that we're getting better. But
We're progressing.
yes,
Well, kind of.
as a
But yeah,
species.
as a species, like we're generally progressing, I'd say. Maybe with a few exceptions. But let's see the next one. I think this is the same
Oh,
one we saw.
yeah.
Uh,
Well,
um,
I did think it's a different view, but it's the same image-ish, same concept, I
it's the
guess.
same thing that's happening. It's just a different angle, it looks like. And this is Hubble snaps a pair of interacting galaxies. The two interacting galaxies make up the pair known as Arp-Mador 608333, seem to float side by side in this image from the NASA ESA Hubble Space Telescope. So I'm going to actually look this up because I'm curious as to how they're interacting.
Yeah, I was like, are they gonna collide like how
Yeah.
Andromeda and the Milky Way is supposed to collide? Or are they like literally orbiting each other? Because that would be really cool. Like, I don't know, that would just be
We can watch this 27-second video of acting here. Oh, is it just the picture?
I think so.
Well, that
But if they like orbit each other, that would just be like how, like, I don't know how to really explain it per se, but just how intricate I guess the universe is so cool sometimes.
Yeah.
Because like the precision, I guess, I don't know if you would call it precision, but just needed that they orbit each other and don't collide. Because I'm assuming just now I'm not gonna pretend I know like a lot about physics, but I'm assuming if two things orbit each other, they have to, like, if they were an inch close, like maybe not an inch, but so much closer, then they would like get sucked into the other one compared to being precisely the exact distance needed apart to actually orbit each other without colliding. So I just think about our universe that is always amazing that happens. Like just things like that, not exactly that scenario per se, but just anything like that is always crazy but beautiful and amazing.
And it just reminds me of how everything is intertwined with everything at the end of the day. Like everything around us is connected to us. And I think that these galaxies that appear to be orbiting each other, I think that just shows how much, like one part of the universe isn't alone. It is all connected.
Yep. Yes.
So let's do one more picture from NASA over here. Let's see. Hubble spies a lonely spiral. The NASA ESA Hubble Space Telescope's Wide Field Camera 3 images a lonely spiral galaxy called UGC 9391.
Oh, they're lonely.
So lonely. After what I just said, too.
They will be okay.
Yeah, and there's still the stars surrounding it.
And sometimes you need to be alone to do some self-discovery anyway, so maybe that's what that little them is doing, It's just figuring itself out before it comes and hangs out with the rest of us.
Yes. Awesome.
Do you want me to show some of the Webb Space Telescope ones?
Yeah, let's do that.
Okay, you ready? Sorry.
Yeah.
I was on this. Oh, there's us. Okay, you can see my screen?
Yes.
Sweet. We can just start with this one. So, Wolf Rayet, I may have pronounced that wrong. 140.
Well, I like it.
I think I saw this on TikTok and someone had explained it, but I'll just kind of read. So this is shells of cosmic dust created by the interaction of binary stars, appear like tree rings around Wolf Rayet 140. The remarkable regularity of the shell's spacing indicates that they form like clockwork during the star's 8-year orbit cycle when the two members of the binary make their closest approach to one another. So that's just like dust caused by the interaction of those stars, which is like really cool if you think like, look at all that.
And I think
I wish I could make it bigger. Oh, I can kind of. I don't know if.
Yeah, that's.
But yeah.
I think isn't the ripple from like I think 3 stars lining up? Was it, or was it 2 stars?
I think it was a binary stars.
Oh yeah, it is a binary star system. Yeah.
But yeah, especially like how the spacing too.
Yeah.
The regularity of the spacing indicates that they form like clockwork, which is also just again
And like, there's the question because it's so far. Are these ripples in space or are they also in time? Does it ripple the time? That would be interesting to study.
Yeah, I was like, that might be above me. But it's an interesting thought. So like, do they, yeah,
Like, is it the space
I like it.
time or is it just the space that's rippling here?
I
I
don't
mean,
have
I
an
don't know
answer
the
for
answer. I couldn't
that.
tell you the answer. It's just a thought I have.
I gotcha. Um, I like it.
Yeah.
And then I was gonna, the pillars of
Yes,
creation,
we have.
because we can view
Because that,
one of them,
yeah.
is the Hubble, and then one is the Webb. And I saw somebody, a TikToker, talking about this recently, and then I think there was some like basically someone had commented asking something about comparing it to something on Earth,
I think it
and
was.
she thought that was really interesting because like obviously that's all we really can think of to compare it to, is like something that we know, so we really can't grasp the full like size of these. Like, so I don't know. It
Like,
might
it's
say
just
down
so
here
big
like,
that like our brains can't comprehend it because we're used to our perception on Earth, where everything is smaller and
yes,
closer to us.
because how I know she mentioned how many light years it was on, 6,500 light, from Earth. I thought that she had mentioned how like many light years the actual pillars are. I guess I can look here quick
Yeah.
to um 5 light years long.
Yeah.
So
Wow. That means it would take light 5 years to travel that far.
yes, from, and how fast does light travel? Do you know off the top of your head?
I want to say 3.8. I got meters per second squared. It's something like that.
So the
Yeah.
Google, this says 186,000 miles per second.
So that is a very far distance for 5 years. That's a lot of seconds.
That is a lot of seconds. Oops, that's us.
Hmm.
What is this? Oh, that was the other one. But yes, and it's just beautiful. Like, especially, and also being able to see it from different telescopes. And I know they, like, I'm gonna look, because I know there's a difference between, like, I think they measure different things.
Yeah. Let's see.
So Hubble examines
Oh, okay.
optical and ultraviolet wavelengths. Webb will primarily observe in the infrared. So that's also really cool that we can see
Yeah.
space in a way, I guess,
Yeah.
from with two different ways of measure. Like, I don't know if that is making sense to you guys, but it is just really cool that we are able to see this, in my
Yeah,
opinion.
we can, the form of light we view it through changes our perception of it too, a little bit,
Yes.
which is very interesting.
I think if I, like, not that we have to choose, but I think this one's the Webb.
I like the web one better too, if I'm being honest.
It's just a
Both
lot more like
cool.
vivid. They are both cool, yes, but it's just way more like
You can
vivid
see all
color
the stars
wise.
in the background. I like that.
Yes. And I don't know. This looks like a hand, like someone's holding their hand. Like, I don't
Yeah,
know. I just started seeing something in it, but yeah, it's just amazing.
definitely. That's just beautiful.
I think that was, yeah, because I guess there's this. I don't know what this is though, but we can Motions of gas around an extremely red quasar. Do you know how to say
I think Quasar.
Quasar? You guys probably could pronounce
I'm
it
trying to
better, but
remember Quasar definition. It's been a while since I've taken physics. A massive and extremely remote celestial object emitting exceptionally large amounts of energy and typically having a star-like image in a telescope. It has been suggested that quasars contain massive black holes and may represent a stage in the evolution of some galaxies. Interesting. So it's basically a galaxy whose center has a black hole, I think.
okay. Isn't the Milky Way have, or is the black hole not in the center? I guess I am not well versed on. I know we have, well, probably maybe more than one black hole. I'm not.
Yeah, a supermassive black hole at the center of our own Milky Way galaxy. But it doesn't emit energy, I don't think.
Oh, okay.
I think that might.
Oh, look at this. Neptune close up. That's cool.
Oh, let me see. That is beautiful. And it even shows the rings. Most people don't even know Neptune has rings.
I don't know if I knew that, if I'm going to be honest, but
yeah, no, but yeah, because Saturn, Uranus, and Neptune, and I think even Jupiter all have rings.
I knew Saturn and Jupiter, I think you said, right? Oh, Tarantula Nebula?
Oh.
That is cool.
That's really cool.
Could you just imagine, like, being able to look up and just, like, see this, like, without needing to tell it? Like, that would be amazing.
Yeah, or, like, I just think of, like, Futurama, like, flying through it all.
Yeah.
Like, just looking out the window and you see this massive, massive nebula, and it's just beautiful.
Maybe we'll be able to develop space travel in our time, I would hope, and then we can all just leave Earth and be space pirates. But
that would be it.
Good space pirates, guys. We do good things, not bad things, but just travel.
We spread positivity.
Yes, picking up odd jobs throughout space. Yeah. Although I mean, if there's other species, that is, because otherwise, what other odd jobs? There wouldn't be jobs to pick up if there wasn't other species out there with us.
Well, and that's the paradox about aliens is, on the one hand, you'd think it, because space is so vast that there would have to be something else out there. But at the same time, like, everything would have to align with how old the universe is. Like, there could have been a species just like humans on a completely different planet, you know, like 4 billion years ago. Like, yeah. It's possible. Or there could be one 4 billion years in the future. And they need the technology to travel and be able to meet us.
If our species survives that long. I have hope for our species, but we got some work to do if we want to survive that long. We got to start working together, not against each other. That's one big thing, but yeah. I don't know if I was going to say anything else there, but
all right. Well, thanks everyone for tuning in to the KSSP podcast. And if there's any science topics you want us to cover, just leave us a comment. You can do that on YouTube, TikTok, Twitter, and Instagram.
And did you say
and
Facebook?
Facebook. Yes, I did forget.
Granted, I consider Facebook and Instagram together just because
they are connected.
Yes, they're connected. That's why I consider that. They are separate, obviously, but all the posts will be connected.
Yeah.
So But if you leave a comment on Facebook, it won't show up on Instagram. Not like connected in that way, but you guys know what I'm saying. I think. I hope.
I mean, depends how well you know how the internet works.
Hey, that's okay. We all can learn.
Exactly. Yep.
Okay. So join us next Thursday. I don't know if we'll always be learning, but I mean, I'm always learning something new every day, but maybe you guys, it's nothing new to you guys, but still join us next Thursday if you want to talk about some more space stuff.
Yeah.
So thank you guys. We'll see you then.
Awesome.